Good morning, my name is Ahmad Fikri Mumtaz bin Osman and I'm here today to talk to you about how me and my team redesigned a wheelchair. Here with my friends Muhammad Aris bin Muhammad Ramzi, Muhammad Aiman Hakimi bin Muhammad Azhari, Muhammad Rushdi bin Ramlan, and lastly Muhammad Nurfala bin Muhammad Nizafar. We are from MEC 435 Class T1 Group 2. A wheelchair was chosen as the subject of this brief study. A wheelchair is a form of mobility aid that helps people get from one place to another. It's a device designed to help people with mobility issues like injuries or disabilities get around more easily. The wheelchair consists of a seat, wheels, and a mechanism that lets its user move forward by pushing the wheels with their hands or feet. Product choice. Reason the product was chosen: we chose a wheelchair for this project after a week of brainstorming. John Dawson of Bath, England invented the Bath wheelchair in 1783. Dawson created a chair with two large and one small wheel. After this discovery, many inventors created wheelchairs, resulting in the wide variety of wheelchairs available today. Following these inventors, we designed a wheelchairs that address all current wheelchair safety, portability, and comfort issues.
For the modification and functionality part, there are several changes that we have made in our wheelchair to tackle all of our problem and needs. Besides that, there are also some part that we add to enhance more our wheelchair compared to the previous model. Okay, for the first modification, we have made a modification at the seat part. From our research, we found that the seat from the previous model is not ergonomical enough and can risk the user the pressure ulcer. So, to solve this problem, we have designed our wheelchair to be more ergonomic, thus it can improve the user blood flow and reduce their muscular strain. Okay, for the second part, we have made a modification at the armrest. The problem that we found regarding the armrest is there are no any cup holder. Because of this, most of these poor people have spilled their favorite drink when traveling on uneven train. To tackle this problem, we have designed an armrest with a cup holder, so it can save space on the table during lunch and prevent the drink from spill during traveling. Besides that, the last part that we add is a seatbelt and a brake. This is very important as our main problem from the previous design is about safety. From our research, we have identified a 770 wheelchair related death, with most of it is caused by fall or tripping over. So for this design, we have add a seatbelt and a brake so that the user can reduce the risk of accident and injuries. Okay, but last but not least, we also made some small modification to enhance more our wheelchair, such as we changed the material for the body from steel to titanium, as titanium have same durability as steel, yet it is more lighter. We also add an adjustable backrest to make it more comfortable for tall people, and lastly, we add a footrest to add an extra relaxation element for the user.
Reverse engineering in the context of wheelchair involves analyzing an existing wheelchair design to understand its components, functionality, and manufacturing process. This process may involve disassembling the wheelchair, studying its individual parts, and examining how they interact and contribute to the overall functionality of the device. The goal of reverse engineering is to gain insights into the existing design, identify areas for the improvement, and potentially create a modified or enhanced version of the wheelchair. While design complexity refers to the complexity and sophistication of the wheelchair design, wheelchairs are complex products that require careful consideration of various factors such as ergonomics, safety, maneuverability, weight distribution, materials, and manufacturing processes. Design complexity arises from the need to balance these factors to create a wheelchair that meets the specifics of users while adhering into the quality of standard and regulation. To manage design complexity effectively, interdisciplinary collaboration between engineers, designers, healthcare professionals, and end users is essential. This collaborative approach ensures that the wheelchair design meet the diverse needs and preferences of users while addressing the technical challenges associated with manufacturing, assembly, and usability. Simultaneously, advanced computer-aided design, CAD software, and simulation tools can assist in managing and visualizing the complex design elements, allowing for iterative design improvements and optimization. Overall, reverse engineering and addressing design complexity in wheelchair design require a comprehensive understanding of the existing product, careful consideration of multiple factors, and a multidisciplinary approach to create a functional, ergonomic, and user-friendly mobility solution.
Finite element analysis (FEA) is a computational method used to analyze and simulate the behavior of a structure or component under various physical conditions. It is also a powerful tool that enables engineers to assess and validate the structural behavior of complex systems, aiding in the design process and ensuring the reliability and performance of various products, including wheelchair, bridges, aircraft, and mechanical components. There are two parts that have been analyzed in this project, which are the leg rest and seat for the wheelchair. First, I will go through to the seat. The material that has been chosen for this part is plastic. Then, boundary conditions are clamped at the end of the part, and the distributed load given is 1000 Newton. According to the result of the analysis, it shows that element quality for criterion stretch 100% in a good condition, while for the aspect ratios 97.88% in a good quality and only 2.12% in a poor quality. From the figure above, the area bounded by the red color shows that the stress is at its most critical, but it is in a small area where the value is 9.56 times with 10 to the power of 4 Newton meter squared, while the blue color shows the least amount of stress that occurs, which is 9.73 times with 10 to the power of 3 Newton meter squared. Next, the leg part. Both sides of the leg part will use the same material, dimension, and shape. The material that has been chosen for this part is titanium. Then, boundary conditions are clamped at the end of the part, and the distributed load given is 300 Newton. According to the result of the analysis, it shows that element quality for the criterion stretch is 100% in a good condition, while for the aspect ratios, 100% is in a good condition and 0% is in a poor condition. From this figure, the area bounded by the red color shows that the stress is at its most critical, but it is in a small area where the value is 1.75 times with 10 to the power of 3 Newton meter squared, while the blue color shows the least amount of stress that occurs, which is 0.0472 Newton meter squared. Now, let's move on to the next member to continue this presentation.
In conclusion, the project successfully achieved its objective of designing and improving a wheelchair to address the inconvenience faced by tall individuals. The team created a wheelchair with a height adjustable backrest, improving comfort and ergonomics. Additional features such as a seatbelt were incorporated to enhance user safety. The design process utilized CATIA software, enabling efficient workflow and accurate drawings. The team's dedication and collaboration resulted in a well-crafted and functional wheelchair. The project provided valuable learning opportunities for team's members and showcased their commitment to excellence. Overall, this endeavor demonstrates their passion for creating impactful solutions in the mobility space. That's all from me. Thank you.